All right, let's begin chapter 7, where you're going to be learning everything that you wanted to know or never wanted to know about quadrilaterals. We're going to start off right here and take a look at angles of polygons in 7.1 before we get to all these specifics about your favorite topic, quadrilaterals. Let's start off and take a look at what is some vocabulary. The first one is a diagonal, which is a segment that joins two non-consecutive vertices. So if I were to draw a diagonal right here in this quadrilateral, it would be from one vertice to the opposite. Okay, we could do the same right here from one to the other. So any two non-consecutive vertices. All right. Next up, we have a quadrilateral polygon. What is that? Or sorry, an equilateral polygon. You should know what an equilateral is, and that means all sides are the same. So in an equilateral polygon, all side lengths are congruent. Next up, we have equiangular polygon, and that's when all angles are congruent. And then finally, when it comes to a regular polygon, that is like the perfection right there, where all sides and angles are congruent to in the polygon. So there's several things that you're going to have to memorize here, and let's take a look at the first one. On Theorem 7.1, we have the polygon interior angles theorem. And the polygon interior angles theorem says that the sum of the measures of the interior angles of a convex n-gon, and remember, the n-gon means whatever number of sides, okay? It doesn't matter if it's 20 side, then it'd be a 20-gon, right? But we use this equation where it's n minus 2 times 180, okay? And that will tell you the measure of the interior angles of a convex. Now that's also important, convex. It's when all the sides, they converge at one and they don't go outwards like this, but they're all inwards. Okay, so if you look at the example right there in the figure that's shown, you can see that if there's 6 sides, then what you end up doing is you'll go ahead and plug in to the equation. We got 6 minus 2 times 180. And so 4 times 180, multiply that together. And we have ourselves equal to 720. So what that's telling us is that all the angles combined, 1, 2, 3, 4, 5, 6, add them all up, they're going to equal 720 one way or another. Think about, let's say, a triangle, right? A triangle has 3 sides. So if I go ahead and put 3 minus 2 times 180, 3 minus 2 is 1. 1 times 180 is 180 itself. And we should already know that the interior angles of a triangle equal 180 degrees. So it all works out quite nicely right there. All right, we go ahead and move along. Next up, we have the corollary to the polygon interior angles theorem. And this says the sum of the measures of the interior angles of a quadrilateral is equal to 360 degrees. All right. The sum of the measures of the interior angles of a quadrilateral. So you could have yourselves a rectangle right there that I showed. All the angles combined is equal to 360. Okay, all angles combined, 360. In that parallelogram, all angles combined, same thing, 360 degrees. If it's a 4-sided figure or a quadrilateral, the interior angles equal 360. Next up, we have our polygon interior angles theorem, or sorry, this time, exterior angles theorem. Okay, that's the key thing right here. We're looking at exterior angles. And it says the sum of the measures of the exterior angles of a convex polygon and one angle at each vertex is 360. So all of these angles, so right here we have a 5-sided figure. Okay, we'll start off with the pentagon. And it's saying that if you were to extend the sides, the exterior angles all combined equal 360 on any convex polygon. So I have my triangle right here. And if I were to extend out the sides, I can go ahead and put right here, this is angle 1, angle 2, and angle 3. Guess how much all those sides or all those angles are going to add up to? You got it, 360. We take a look at this quadrilateral right here. Extend it out, 1. Extend out this side, 2, 3, 4. I extended all 4 sides to create 4 exterior angles. And guess how much those exterior angles are equal to? You got it, 360 degrees. All right, so all the angles of the exterior will always equal 360. Doesn't matter how many sides you have as long as it's a convex polygon. All right, good deal. All right, so now that's enough for us to solve some of these important questions in 7.1. Let's start off and take a look at number 1 right here. We'll look at the sum of the measures of the interior angles of the indicated convex polygon. So you have to remember what the names of some of these polygons are. If you forgot, remember I asked you to remember all the way from 3, which is your triangle, and all the way up to like 12, right? Your dodecagon. So if you don't know those names, then you might get in trouble when it comes to answering some of these questions. So go back and remember all the different names of the polygons from 3 to 12 at least. All right, octagon right here is an 8-sided figure. So if we use our equation, remember n minus 2 is equal to 180. I'm going to go ahead and put 8 minus 2 times 180 and get my answer to the polygon. All right, so 8 minus 2 is 6. 6 times 180 ends up equaling 1,080. Remember, that is how much all the interior angles inside of that 8-sided figure will be. Okay, continue on with number 2. We've got ourselves a 15gon, so all you need to do is put 15 minus 2 times 180 to get your answer, and this right here will be 2,340. All right, angles to the interior angles of a convex polygon. All right, if we were to do number 3, which is 24, you'd go ahead and just put 24 minus 2 times 180. But don't forget, these are all the sum of the interior angles. Okay, not anything else. All right, moving along right here. Let's take a look at number 4. Now when we look at number 4, the question is all about the sum of the measures of the interior angles of a convex polygon are given. Okay, and we're trying to classify the polygon by the number of sides. So we want to first figure out, well, how many sides are there? And then when they say classify, you have to give that name. If you don't give that name, then you're going to get the wrong answer right here. Okay, so make sure you got to know, well, what are the names of the polygons from 3 through 12? And then after that, you can use n-gon. Well, this time, since they gave us what the angles all equal, we'll take our 900 and set that equal to n minus 2 times 180. And then we're going to go ahead and solve for n. All right, so pretty simple. We go ahead and in order for us to get n by itself, I got to get rid of that 180. So let's go ahead and divide both sides by 180. 900 divided by 180 ends up equaling 5. So I have 5 is equal to n minus 2. So in order for me to get n by itself, we'll add 2 to both sides, and n is equal to 7. That is like half your answer. Is that the actual answer? No. Because remember, you have to classify it by its sides. So let's go ahead right here, give it the name of a 7-sided figure, and we have 2 names that are acceptable right here. We have heptagon and also septagon. So make sure you know both of those terms. Okay, so pretty straightforward. Let's skip number 5 and take a look at number 6 right here. So we'll start off, since they gave us the total, the sum of the exterior or interior angles. We'll take that 2,880. We'll set that equal to n minus 2 times 180. And we will repeat this process. We'll take 2,880 and divide that by 180 to both sides. And so we have n minus 2. And that is now equal to 16. We'll add 2 to both sides. And n is equal to 18. So what do I do right here? In this instance, remember, anything above 12, you can go ahead and write the number, and we'll write 18. Gone. All right, so we now know what is the polygon with the interior angles of 2,880 degrees. Okay, let's go ahead and move on right here. We've got several different scenarios that we're going to look at when we take a look at number 7, 8, 9, and 10. You got to be careful with what they give you based on the angles and the number of vertices and or angles that there are. All right, so number 7, we're trying to figure out, well, what is the value of x? Okay, in order for us to do that, I put in that rectangle that's in red 2 things. First, we got to find the sum of the interior angles, and eventually at some point you're going to memorize them. You already know what it is when it's a triangle, 180. So finding the sum of the interior angles is important first and foremost. After that, you're going to have to solve for x by making an equation. So make sure you create an equation when we do these problems here. And so number 7, okay, we have ourselves a 4-sided figure. Step 1, let's find the sum of the interior angles. Maybe you already know them, but maybe not. But if you don't, we got step 1. We got 4 minus 2 is equal times 180. All of that right there. 4 minus 2 is 2. 2 times 180, 360 degrees. So now that we know the sum of the interior angles, we can go to step 2. Is solve for x. Well, how do I solve for x, or what do I need to do? We take all the angles right here, and I'll start with x plus 45 plus 65 plus 95, and we'll set that equal to 360, because that's what the sum of the interior angles will end up equaling. And then we can go ahead and find x. Okay, so go ahead and put all that together. You know, you add 45 plus 65 plus 95 and have all that fun. All right, so let's go ahead and do that. I've got, so x plus 205 is equal to 360. And when you subtract 205 to both sides right here, then you should end up with 155. And that right there is angle X. All right, let's take a look next up at number 8. All right, so first off, we got to figure out, well, how many sides do we have in this polygon? And then so we'll figure out the interior angles. I see we have 1, 2, 3, 4, 5, 6 sides. Okay. So there's 6 total sides. So let's go ahead to find the interior angles. We'll do 6 minus 2 times 180. All right. So from there, we should figure out that we have 720 degrees. All right, so let's take each and every side or interior angle, including that X, and set it equal to 720. So we go to step 2, and I've got X plus 140 plus 130. And as you can see, I'm writing down all of these different angles in my equation that you should have in your homework. We also have angle K. We need to know that that's 90 plus 150, and all of that is equal to 720. All right, so when you get X by itself in the end, right here, we'll cut to the chase. X is equal to 90. All right, 2 steps, and you can solve these problems out. Next up, let's take a look at number 9. All right, so it looks like we have a total of, we got 1, 2, 3, 4, we got 5 sides. We got ourselves a pentagon here. A funny looking pentagon, right? Not our normal one. So we got 5 minus 2 times 180. Right, we'll do step 1 right here. And so we end up with 540 degrees. And then for step 2, let's go ahead and solve for X. One of my angles is X. We have plus 100, plus 70, plus another X, and then plus 90 degrees. And all of that's equal to 540. Okay. So we can go ahead and simplify all of this out right here. Looks like we have like 2x plus 260 is equal to 540. And then you can go ahead and solve this out, right? We have 2x ends up equaling, let's see, we got ourselves 300 and, or let's see, 280. And then divide both sides by 2, and x is equal to 180. And finally, number 10. This one's a little bit different because, hey, look, these are the exterior angles, not the interior this time, right? A little bit different. We have exterior angles here. So what do? Well, what do we know about exterior angles? Oh, they equal 360. So we're going to go ahead and come up with an equation right here where we take every angle, 98 plus x plus 162 plus that last angle, 4x. And let's set this equal to 360. Why 360? Because that is the sum of the exterior angles here. And let's go ahead and simplify this out. Combine like terms, 5x, and then we got ourselves plus, let's see, we got 260 is equal to 360. We'll subtract 260 to both sides and end up with 100. And divide both sides by 5. And x is equal to 20. And there you go. We have now concluded chapter 7.1. Now know the angles of polygons inside and out.